Bismillahirrahmanirrahim. In today's lecture, we will discuss the resolution of vector into its rectangular components. Let us say we have a vector, this vector f, and we want to resolve it into its rectangular components. We have discussed in previous lectures about the rectangular components. In two-dimensional space, this x-axis x component and on y-axis this y component. These two components are rectangular components because they are making an angle 90 degree with each other. And if we have this force and we want to resolve it into its rectangular components, then it will be like on x-axis the projection of this vector on x-axis will be fx, and its projection on y-axis will be fy. And this dotted line and this fy, these are parallel lines, so they are equal, so we can draw this fy here in order to make a triangle. So this is a triangle, and from this triangle we will find the value of fx and fy in order to find the magnitude of this vector force f. Finding x component first. As we know that cos theta is equal to base divided by hypotenuse, so here the fx is base and and this f component is the hypotenuse. Putting the values, we will get cos theta is equal to fx divided by f, and from here fx is equal to f cos theta. Similarly, finding the y components, we will use the trigonometric ratio sin theta is equal to perpendicular divided by hypotenuse. So here the perpendicular line is fy and hypotenuse is again the vector f. Putting the values here, sin theta is equal to fy divided by f. From here fy is equal to f sin theta. So by this way we have find two components that are fx component that is equal to f cos theta and fy component that is f sin theta. Now in order to find the magnitude and direction of this vector force f, we will use the Voorhis theorem. According to Voorhis theorem, we know that this base square plus perpendicular square is equal to hypotenuse square. Putting in equation hypotenuse square is equal to base square plus perpendicular square, we will get hypotenuse square, this is f, is equal to base square, that is fx, plus perpendicular square, that is fy square. So the equation is f square plus fx square plus y square. Taking square root both sides, this square will be cancelled out with the square root, so the final equation will become f is equal to fx square plus fy square under root. Now this is the magnitude of this vector, the value of this vector. So how we find the value of this vector? We first find the value of fx, that is fx is equal to f cos theta. Then we find the value of fy, which was fy is equal to f sin theta. Then by Voorhis theorem, we use this equation to find the magnitude of this force f. Now in order to find the direction of this vector, we will find the theta here with x-axis. So for the theta to find, we use the trigonometric ratio tangent theta, which is equal to perpendicular divided by base. Here the perpendicular is fy and base is fx. Putting the values in this equation, we will get fy divided by fx. Or we need to find the theta, the direction. So then this equation tangent theta is equal to fy divided by fx will become theta is equal to tangent inverse Fy divided by Fx. So in today's lecture we have discussed the resolution of vector into its components, and then we find the magnitude and direction of a vector from its components. Thank you, and remember to subscribe the channel for further videos on physics and electronics.